It's the 7-inning stretch of the final game of the World Series. I don't know who you're rooting for, but I'm rooting for the Royals. I guess when you're listening to this, you'll know if I won or not. Anyhow, for the past couple days, we've been solving absolute value equations. And I just want to relook at one again. And so this equation, I want to remind you that what this is saying is this distance in here is going to be 5 from 0. So we know that there's a distance this way that's 5, and there's a distance this way that's 5. And so we've been saying, then set up two equations. One equal to 5 and one equal to negative 5. I'm going to solve this out. I'm going to subtract 1. Get x equals 3. I'm going to subtract 1. I'm going to get x equals negative 3. Interesting how that works. That doesn't always work like that, does that? Oh, because I made a math mistake. So that typically is 2. So if I plug 2 into this x, I get 4 plus 1. The absolute value of 5 is 5. If I plug negative 3 in here, I get negative 6 plus 1. That's negative 5. The absolute value of negative 5 is 5. Okay, what I would like to propose is this any different? So I solved the first one. So this distance has to equal 5. And I'm also going to say the opposite of that distance is going to equal 5. There's not really any difference. I'm going to subtract 1, and I'm going to get 2. I'm going to divide this side by negative 1. I'm going to get 2x plus 1 equals negative 5. I'm going to subtract 1, and then I'm going to divide by 2. There's not really any difference. No matter if I say 2x plus 1 equals 5 and it also equals negative 5, or this distance is 5 and the opposite way of this distance is 5, I'm still going to get the same solutions. I believe that this is an easier way to solve absolute values, especially for what we're coming up with inequalities. So let's just look at this. We're going to solve an inequality. Now, all an inequality means is that I don't have an equal sign. I have an inequality. I have something that's greater than and equal to. So this is saying this distance from whatever, from 0, has to be greater than or equal to 5. So if I were to think about that, all of these numbers, the distance is greater than or equal to 5. But because of absolute value, all of these numbers, the distance is greater than or equal to negative 5. Right? Okay, so what that really is saying is that 2x plus 1 has to be greater than or equal to 5, and 2x plus 1 has to be less than or equal to negative 5. And there's a rule. If I have greater than or equal to, I do the normal, and then I flip it and change the sign. Well, I don't like rules. I hate rules, actually. I hate them with a passion. So I would rather use what we were doing before. I would rather say 2x plus 5 is greater than or equal to 5, or the opposite of 2x plus 1 is greater than or equal to 5. Because what's going to happen now is I'm going to go ahead and subtract 1 and divide by 2. Over here, my first step is going to be to divide by 1 on both sides. Now, what happens when I divide by 1 is this negative and this negative cancel. So I get 2x plus 1. But remember, when you divide by a negative, you have to flip the inequality. So I'm going to flip it this way. And look what I end up with. This is the same as this. But I'm not memorizing a rule, and I'm not remembering the math because that will get confusing. This is the math behind that, but I want you to see this. So now I subtract 1, and I divide by 2. Whoops, wrong way. So now if I want to put it on a number line, here's 0, here's 2, here's -3, and this says x is greater than or equal to 2. So greater than or equal to 2 are all these numbers here. And this says x is less than or equal to -3. So it still ends up looking like my picture. Now let's just pick something. I like to pick 0. And if I plug 0 in, should it work or should it not work? Well, it's not in my highlighted region, so it shouldn't work. If I put 0 in here, I get the absolute value of 1 is greater than or equal to 5. Well, that's not true, so 0 doesn't work. Let's try a number over here, 4. Let's try 4. If I put 4 in here, I get 8 plus 1. The absolute value of 8 plus 1 is definitely greater than or equal to 5. Okay, so these numbers work. Let's pick a number over here. Let's pick -3, the number right on the dot. If I pick -3, I get -6 plus 1, which is -5. Is the absolute value of -5 greater than or equal to 5? Yes, it is. It's equal to 5. So this would be my solution. Let's look at another example. This is example on the Solving Absolute Value Inequalities worksheet that you took home. This is the first example. So the notes that we just were talking about, those have to be in your notes, but now I'm going to start working on this worksheet. All right, so this is the absolute value of 5 minus 2x is less than or equal to 3. So I'm going to write it twice like we did before. I'm going to say 5 minus 2x is less than or equal to 3, or the opposite of 5 minus 2x is less than or equal to 3. I'm going to subtract 5 to get -2x is less than or equal to -2. I'm going to divide by -2, and when that happens, I flip. -2 divided by -2 is 1. So right in here, I divided by -2. All right, over on the right side, I'm going to divide both sides by -1. And when I do that, I'm going to get 5 minus 2x. I divided by a negative, so greater than or equal to -3. I'm going to subtract 5, and I get -2x is greater than or equal to -8. I'm going to divide by the -2, and x is divided by a negative, so I'm going to flip it again, less than or equal to 4. So let's see what that looks like on our number line. Here's 0, here's 1, here's 4. I put the 1 on the number line, I put the 4 on the number line, and I always put a 0. I don't need to put 1/2 or 2 or 3 or 5 or 6 or -1 or -2. Just 0, the first part of my solution and the second part of my solution. Now, I want x to be greater than or equal to 1, but I also want it to be less than or equal to 4. So let's look at it a different way. I want to be greater than or equal to 1, but it also needs to be less than or equal to 4. So the only place that I have where they can be both of those is this region right here, where I have the orange highlighted. Let's look at example 2 from that worksheet. Well, the first thing I have to do is I have to get these absolute value bars by themselves. Nothing can be on this side with them, and I have this too. If I were to read this mathematically, this would say 2 times the absolute value of 4x minus 4 is greater than 8. So this is 2 times this. In order to get rid of it, I'm just going to divide by 2. And I get the absolute value of 4x minus 4 is greater than 4. That's a lot of 4's. So now I'm going to do my 2 equations. 4x minus 4 is greater than 4. And the opposite of 4x minus 4 is greater than 4. I'm going to add 4 over here. So I get 4x is greater than 8. And I'm going to divide by 4. Now some of you had to put little notes over here, add 4, and then divide by 4. Okay, make sure you're doing what you need to do to get these notes correct so you can use them in class. I'm going to divide by -1. I'm going to get 4x minus 4. Dividing by a negative flips my inequality, -4. I'm going to add 4 here and divide by 4. 0 divided by 4 is 0. Okay, so maybe you had to put add 4 right here, divide by 4 here. Now let's put it on a number line. Let's change that. Okay, so what this is saying is any x that's greater than 2, if I put it in here, I'm going to get an answer over here that's greater than 8. And any x that's less than 0, if I plug it in here for x, and I work this side out, it also will be greater than 8. So let's just go ahead and do that. I want to be x is greater than 2, open circle, greater than. X is less than 0, open circle, less than. Now let's try it. What if I actually were to pick 0? If I put 0 in here, I'd get -4. The absolute value of -4 is 4. 2 times 4 is 8. Is 8 greater than 8? It's not greater than, it's equal to. That's why I have an open circle. If I were to pick 3, 4 times 3 is 12, minus 4 is 8, times 2 is 16. The absolute value of 8 times 2 is 16, and that definitely is greater than 8. So these sections work. What if we were to pick 1? If I plug 1 in here, I get 4 times 1 is 4 minus 4, that's 0. 2 times 0 is 0. 0 greater than 8? Nope, it's not. That's why this section in here is not highlighted by the orange. None of these numbers in here would work in this equation. These would all work in this equation. What I'd like you to do now is do the 2 now you try problems that are next on the solving absolute value inequalities. Please do not do the rest of the worksheet. I would like you to just try the first and second now you try it. Thanks. You guys have a great night and a happy Halloween on Friday.